We're moving into section 3.5, which is systems in 3 variables. And before we do that, I want to show you this little, call it a solve it problem as part of the Pearson textbook. But really it's just kind of designed to get us thinking about a certain topic. So here's the situation. We have 2 of the A boxes and 1 B box on the right side of the scale. And as you notice, the scale is even, so these 2 A weights equal whatever B is. And then over here we have C on one side and 3 A's on the other. And then on the third set of scales, B and C together is equal to 10 pounds. So we're trying to figure out how much each box weighs. So if you want to pause a minute and try to kind of figure this out, feel free. But kind of in general, my process for this is to think about, well, okay, B plus C has to equal 10, but I know C is 3 A's, so I can take my 3 A's here and plug them in for C, and then I know B is equal to 2A, so I have 2 A's here and 3 A's here, so 5 A's total gives me 10 pounds. That means A has to be 2 pounds. Okay, and if A is 2 pounds, then 2 pounds and 2 pounds is 4 pounds. B is 4 pounds. And then, again, A is 2 pounds, so 2, 4, 6. C would have to be 6 pounds. But this really just kind of gets us thinking of the idea of a system of equations with 3 variables. Now, what does that mean? So again, we're moving into section 3.5. Systems with 3 variables. Now, when we learned about systems of equations with 2 variables, we thought about our visual on our standard x-y axis, on our standard coordinate plane. When we found a solution to a system of equations, that was where our 2 lines intersected. Now, in 3 variables, we still kind of have that same idea, but instead of being our standard x-y axis, we are talking in 3 dimensions now, where we have an x, a y, and a z. Right. So we have one axis that's running left and right, one that's running forward and back, one that's running up and down. So this is really kind of like the corner of a room. Okay, your x and your y axis are the floor, and then your z axis is the corner of the wall going straight up. So that's kind of what we're looking at there. When we have a system with 3 variables, we're talking about lines still, but it's in 3 dimensions. So that's a little bit weird. Anyway, this first example or this first video was to just kind of introduce a system with 3 variables and just kind of let you know what it's all about. Our next video will actually solve